All right, so this is chapter 12, section 1. And in this chapter, we're going to be focusing on adding and subtracting. In this section, we're focusing on adding and subtracting matrices. Our learning objective is to add and subtract matrices and to solve matrix equations. We're going to use the word corresponding elements quite a bit coming up, so it's important that we know what they are. And they are elements in the same position in each matrix. All right, so let's look here at our key concept, matrix addition and subtraction. To add matrices A and B with the same dimensions, please, you have to have the same dimensions in order to add the matrices. You add corresponding elements. Similarly, to subtract matrices with the same dimensions, you subtract corresponding elements. So if we look here, this guy here in the top left and this guy here in the top left are going to be added together when you add the matrices together. This guy in the top right and this guy in the top right are going to be added together when you do your matrix addition. Same with the bottom left and the bottom left. Those two elements get added together, and the bottom right adds with the bottom right. And it's the same when you're subtracting. Each element in its position will subtract with that other element in their position. All right, so let's see how that plays out. We're going to do two things. We're going to add A and B, and then we're going to subtract A and B and see what we get. So let's go A plus B. Okay, so you want to put down the matrix brackets. Is negative 12 plus negative 3 and 24 plus 1, negative 3 plus 2 and 5 plus negative 4, negative 1 plus negative 1, and lastly 10 plus 5. And then you're going to go ahead and do that operation. Negative 12 plus negative 3 is negative 15. 24 plus 21 is 25. Negative 3 plus 2 is negative 1. 5 plus negative 4 is 1. Negative 1 plus negative 1 is negative 2. And 10 plus 5 is 15. So that is the answer to A plus B. So now we're going to do the same thing. And if you watch here, I'm going to be Sneaky Panda. And just copy this item. So instead of plus signs, we are going to put in minus signs. So this is going to be a minus, this is going to be a minus, this is going to be a minus, and this is going to be a minus. So negative 12 minus negative 3 is the same as negative 12 plus 3, which is negative 9. 24 minus 1 is 23. Negative 3 minus 2 is negative 5. 5 minus a negative 4 is 5 plus 4. Negative 1 minus a negative 1 is 0. And 10 minus 5 is 5. Reasoning. Is matrix addition commutative? And you'll look, if I were to say, instead of negative 12 first, if I were to put negative 3 first, would that make a difference? And it would not, so it is yes. Since addition is commutative, so is matrix addition. right, so the next item we're going to look at is a matrix equation, and that's an equation in which the variable is a matrix. Awesome. So let's look at our example and see how we can apply that to our got it problem. So the first table shows the teams with the 4 best records halfway through their season. The second table shows the full season records for the same 4 teams. Which team had the best records during the second half of the season? So we're going to write a 4x2 matrices to show information from the 2 tables. So if you look, we're going to write a win-loss column that matches this table, and then a win-loss that matches this table. A is the first half records, B is the second half records, and F is the final records. So the next thing we'll do is we'll solve for A plus B equals F. So in this case, we want the B, so we are going to subtract A from both sides. So we get F minus A. So when we do that, we get a win-loss record for B the second half of the season. Team 2 had the best record with 38 wins and 3 losses during the second half of the season. All right, so let's apply that to our got it problem here. If B is equal to this 3x3 matrix and C is equal to this 3x3 matrix, and A minus B is equal to C, what is A? So I care about A. I'm going to add B to both sides, so I get A equals C plus B. So I'm going to take these guys and add them together. So our A is, make a big enough matrix, 1 plus 2, 6 plus 0, negative 1 plus 0, 2 plus negative 1, 6 plus negative 3, 1 plus 6, negative 1 plus 2, negative 2 plus 3, and 4 plus negative 1. So when everything is said and done, I have 3, 6, negative 1, 1, 3, 7, 1, 1, 3. And that's as hard as that gets. All right, so we're going to use the identity and opposite matrix, and just to let you know, identity matrix is +1, and the opposite matrices is when you change the signs of everything in your matrix. So in this case, if I added 0 to each of these elements, I would get the exact same matrix that I started out with. And if I added the opposite of everything, each of these elements, then I would end up with the identity matrix. So let's look at this got it problem and see if we can't find the answers. So what is 14 plus negative 14? 0. What is 5 plus negative 5? 0. 0 plus 0? 0. Negative 2 plus 2 is 0. And then if I were to add 0 to each of these elements, I would get it, the original matrix. Easy, right? All right, so let's get into some content. Properties of matrix addition. if A, B, and C are m by n matrices, then the sum of the two matrices is also an m by n. This is called the closure property of addition. I definitely need to have you put this in your notes. If you can either do it A plus B, or you can do B plus A, that's the commutative property of addition. We talked about that earlier. You can go A plus B and then add C, or you can go B plus C and add A and it would be equal. That's the associative property of addition. There is a unique m by n matrix, so such that when we add it to A, we get A. That's called the additive identity property. And for each A matrix, there is a unique opposite, minus A, negative A, such that A plus negative A is 0. It's called the additive inverse property. So equal matrices have the same dimensions and equal corresponding elements. Let's do this. Number 4. Here's what we're going to apply. So we are given that this matrix is equal to this matrix. So these matrices are equal. So when we want to find the values of x, y, and z, we are going to write down that each of the elements in the matrix are equal. So that means x plus 3 is equal to 9. Y minus 1 is equal to 2y plus 5. And just for fun, x plus 1 equals 7. Boop, boop. We don't have a z in this equation, so that's good. All right, for this case, if I subtract 3 from both sides, I get x is equal to 6. And that matches if I were to subtract 1 from both sides. So I know for sure x is equal to 6. In this case, I am going to subtract y. Get negative 1 equals y plus 5. And I'm going to subtract 5 from both sides. And y is equal to negative 6. So for A, x is equal to 6 and y is equal to negative 6. Now let's do the same thing for B. If we look here, we have a subtraction rolling on right here. So let's do the subtraction first. I have z minus 10. Negative 3 minus negative 4 is negative 3 plus 4, which is 1. I have 3x minus x, that's 2x. And I have 0 minus 2x plus 6, sorry, 2y. And we know it is equal to 2, 1, 8, and 4y plus 12. All right, so we are going to match this up. So we got z minus 10 equals 2. We have 2x equals 8, and we have negative 2y minus 6 equals 4y plus 12. So let's solve this first. We're going to add 10 to both sides. And z equals 12. I'm going to divide both sides by 2 here, and x is equal to 4. And then I'm going to do a little bit more sophisticated solving. Add 2y to both sides. And I get negative 18 equals 6y, so y must be equal to negative 3. Boom. And that's it for this lesson.